Okay guys, so since I'm not here today, I'm going to cover the notes via a video. You'll take notes on here like you normally do, and then there'll be some problems on the back that you can try, and then we'll see how you do on the homework tonight as well. The focus of the video is going to be about evaluating logarithms without a calculator. And we've done this before. We have evaluated logarithms. That means to find the value of. Okay, so all of the logs on the page here, they all equal something. They all equal a number. Whether it's an ugly number or a good number is to be determined. So if you look at the first one here, first of all, if you don't see the little 10 there, it's implied to be 10, so there is technically a base of 10 on each of those logs. And we know that we would normally ask ourselves the question, 10 to the what equals 250 for that first log, and then 10 to the what equals 4 for the second. The problem is that is not going to be a nice exponent. There's no exponent I can put on 10 to get 250, and there's no exponent I can put on 10 to get 4. So while that's perfectly reasonable to ask that in your head or on the piece of paper to write what I have, it doesn't get you anywhere. You're sort of stuck if you go with that method. So we need a backup plan. And luckily, the previous days we have spent talking about what the heck happens when I add two logs together with the same base. And we know that we can condense into one log with that base of 10 by taking the insides and multiplying them. Wow. 250 times 4 is 1,000. Now that actually helps us, because if I now ask myself the question, 10 to the what equals 1,000, well, that means that this whole log equals 3. And we got that log by just condensing using our properties of logarithms into a single log here, and I was able to get the answer. As the logs originally were written, I was at a loss. I wasn't going to be able to figure that out. So, condensing can help us evaluate. Okay, so we have a couple that I'm going to walk through with you here. We have log base 6 of 2 and log base 6 of 3. 6 raised to what gets me 2, that's not a good answer. Neither is 6 raised to what gets me 3. So instead, we're going to condense into one log, and I know that I can take the insides and multiply them, and 2 times 3 is 6, and then this just became a very easy problem. What exponent do I put on 6 to get 6? That's 1. Here we're subtracting these two logs with a base of 5. Now individually, I don't know what exponent I would put on 5 to get 200, and I don't know what exponent I would put on 5 to get 8. But I know that when I subtract two logs with the same base, it is the same as dividing the inside. So I take the 200 and I divide it by 8. So you can actually write it as a fraction if you want it first, but then you'd want to realize that that's actually just 25. And so what exponent do I put on 5 to get 25? It's a 2. So that whole expression is equal to 2. This one, we've got 3 different logs, all again base 10. So a couple things I can do. One, I'm going to move that 1/2 as an exponent on the 400. And I also see that I am subtracting those two logs, so we can divide the insides. Again, base of 10. We can write it in there if we'd like. Now, it would be important to realize that if I take 400 and raise it to the 1/2, that it's the same as square rooting it. 85 divided by 17 is going to be 5. And when I square root that 400, I get a 20. All right, so we just went from 3 logs to 2, and I took care of that 1/2 by realizing it's going to be the square root of 400. Now I'm adding those logs, so I get to take the insides, multiply them together, and I have log base 10 of 100, and this just became something I can answer. What exponent do I put on 10 to get 100? It's a 2. So it's sort of like a little puzzle and putting all the pieces together there. So if I look at the problems below, I sort of switch gears a little bit. We have these two pieces of information they are given to us here. Okay, I have a log base 3 of 7 equals 1.77. So if I take 3 and I raise it to 1.77, I should get about 7. Probably a little bit of rounding error in there. And then 3 raised to the 2.1 gets me 10. Now, just using this information that's given and perhaps some other logs that I may already know, I want to try to evaluate these logs over here on the left. For instance, log base 3 of 70. Well, I don't know what exponent I would put on 3 to get 70. But I do notice that I could think of that 70 in terms of the 7 and 10 that I'm given. 70 is the same as 7 times 10. And I know that I could actually expand that into 2 logarithms by adding those 2 logarithms together. And those 2 logs, I know what they're equal. This first one's equal to 1.77. This next one's equal to 2.1. I can add those together, and that's going to get me 3.87. So the exponent that I would put on 3 to get 70, 3.87. If you think about it, I know that 3 to the 3rd is 27, 3 to the 4th is 81, so my answer of 3.87 does make a little bit of sense. So here we didn't condense, we actually started with 1 log. We expanded into multiple logs to help us answer the question. That's a little bit different than those problems we looked at above. Above we were condensing, here expanding helped us evaluate. So on the next one, I see that we have the fraction in there. So really that's the same as taking these 2 logs and subtracting them. And I have those 2 logs. So 2.1 minus 1.77, that is going to equal 0.33. All right. Now the next one, we have 100. So lots of ways to think about 100. It's 2 times 50. It's 4 times 25. But the best one to think of, given our current situation, is how 100 is 10 times 10. And again, if I'm multiplying on the inside, I break that apart into 2 separate logs that I add together. So 2.1 plus 2.1 equals 4.2. Log base 3 of 30. Now 30, lots of ways to think of that. 2 and 15, 3 and 10, 5 and 6. Now as soon as I said 3 and 10, I think, wait a minute, I had a log base 3 of 10. So let's go that route. Log base 3 of 3 plus a log base 3 of 10. Well, log base 3 of 10 is something that's given to me. That's 2.1. Log base 3 of 3, that's something that I just know. That's just equal to 1. So 1 plus 2.1 is 3.1. Now, when you flip this page over, what I want you to do is first try the problems yourself. Okay, so on the back, there's a lot of example problems. I want you to pause the video right now. Pause the video. Go ahead, complete these as best as you can. When you're done, play the video to see what the answers are. All right, so you can see what you were able to do and what you were not able to do. Okay, so make sure you pause the video and try these on your own. When you're ready, you hit play. Okay, so hopefully you've paused the video, you've done these on your own. Now we're going to see how you did on this first one. I can't evaluate either of those logs as they are, but I can condense them into one log by taking the insides and dividing them. So that's a 1/3. Now 6 over 54, we would want to notice that that reduces to 1 over 9. And so the exponent that I would need to put on 1/3 to get 1 over 9, so think about that, 1/3 raised to what power gets me 1 over 9? That's got to be a 2. Now on the next one, move the power of 2 first, or that number in front becomes a power of 2. And so that becomes log base 4 of 36 minus log base 4 of 9. I'm subtracting those, so I'm going to take the insides and divide them. 36 divided by 9 is 4, and then log base 4 of 4, that's a 1. All right, now we have some decimals here. I'm adding these logs, so I'm going to go ahead and multiply the insides. 0.2 times 1.2 is actually 0.24. And I'm still subtracting that second log. By the way, these are both base 10. We can write that in. I'm subtracting those two logs, so I'm going to take the insides and divide. And that looks like an ugly fraction, but that actually reduces to 1 over 100. The exponent that I put on 10 to get 1 over 100 is a -2. All right, when we switch gears here, just using our own knowledge about some particular logs with a base of 5 and these two logs that are given to us, we want to try to figure these out. So first one shouldn't be too bad. I'm dividing the inside, so I'm going to go ahead and subtract those two logs. And I have exactly the values of those two logs. So I'm taking 1.49 minus 1.37, and that equals 0.12. Log base 99, I think of that 99 as a 9 times 11, and if I'm going to multiply the insides, I can break that apart into two separate logs. Log base 5 of 9 is 1.37. Log base 5 of 11 is 1.49. And then when I add that together, I think I get a, let's see, a 2.86. All right. 1 over 99. Well, I actually just found the answer to log base 5 of 99. I could actually use that 2.86 if I want to. And I see that subtraction, so log base 5 of 1 minus log base 5 of 99 Well, I know that second one. I just answered it, 2.86. What exponent do I put on 5 to get 1? Oh, that's a 0. 0 minus 2.86 is negative 2.86. And this should actually make a lot of sense. If 5 raised to the positive 2.86 gets you 99, then 5 raised to the negative 2.86 should get you the fraction 1 over 99, because we know negative exponents make things fractions. The last one, a little tricky. I certainly wouldn't know what the square root of 11 is, but I know that I could represent that as an 11 to the 1/2. And I know if I have that 1/2 on 11, one thing I could do is move that in front of the log. Log base 5 of 11, that's something I have, 1.49. 1/2 times that, so I basically have to cut 1.49 in half, and that's going to be 0.745. Okay, so hopefully the process is making sense to you. What I want you to work on for now and tonight for homework, whatever you don't finish, 9.5 homework document, 1 through 3, all of them. And we'll check that tomorrow.